Hello everyone and welcome to another episode of No Orientation Programming. I'm Joe and today we will finish our file executing process, hopefully. I had an idea and I think I'm greedy again because I want to have everything in this process. So let's see. Okay. So this deserves a wiki page. So I want to write down all the requirements. 14, that is file executing. Oh. Okay. So we have forking, and forking is, can I add this thing to the wiki page? I think I have forgotten something last time. That is Plantech. Yes, exactly. So I think we should change something. That is, the threads are reading the code and they are writing to the data, but they are also reading to the data. So we say the threads are reading from the data as well. Okay, so this seems to be fine. Okay, let's check this out. No, come on. So, yes, looks fine. Okay. So we have a couple of requirements for this thing. We want to have full communication with the child. That is std in, std out, and std error. Then we want to have signals. Then we want to have arguments. And we want to have yes, that's it, I think. And yes, the return code, of course. I think that's it. Next, We want to avoid the shell. But still we want to support piping between multiple child processes. And that's it. That's this point is, let's see, the third point is the reason why I'm using Bash very often instead of Python, because in Python we have nodes, file execution, these two. Links list. Then we have this one. Oh, come on. We have docs Rust. And then we have docs Python. Oh no, come on. Rust is spreading around. So, subprocess Rust. And here we have the subprocess in Python. Yes, exactly. So this thing is able to read the output of the child process, which is the std out and standard out and standard error. It is able to give us the return code. We can decide if we want to execution. That's interesting. Use the exec builder to execute a pipeline of commands and capture the output. That's interesting. We want to have something similar to this. That's quite cool already. That looks quite cool. Unfortunately, we have this thing, but I think we could avoid this. But something like this. I want to have something like this, so we are able to concatenate the sub-processes. Okay. But first of all, this thing should just execute one program. Last time we executed. Yes, we were executing. Running. Let's see. We are testing stdio. This what is this thing doing? stdio providing. We should have an open port at this location. Why? Sick user. We see that the child should be running. Yes, and one issue we had last time, the error with the free was because we used the wrong exit function. This exit function is closing a program if in a different manner. That is, it's just closing the file handles, the open file handles. And not doing all the executing all the destructors. So this is fixed. This should be fixed, hopefully. Okay, we have the redirection. Something is strange because if yes, I can see this is an error line. We get this line if we send the user signal to our child. So everything must be working as expected, but and we see the child is running, yes, but we should have an let's check something. Build native stdio. Verbosity 3, let's check verbosity 5. Ninja stdio. System debugging. Okay. Processing. Is this thing... Okay, I think we have... We are stuck at a certain point in the test program, I think. I think at this line. Who is it in? Standard in, yes. Should our test program be... Should this thing block by reading the standard input? I don't know. Because... Okay, go sleeping. If we say go sleeping. Okay, I think, yes, it was intended to be blocking, I think, at this point. Okay, then I'm not sure if this is okay and useful for us. What is the next thing we should do? Yes, we defined the interface. The interface, yes. Ooh, we have to change a lot. Okay. We make another struct that is called entry file execution. And we have an std string command, and we have an std vector of std strings. Arguments. And we have an std vector of these entries. The list of commands. And in the constructor we say reserve for entries. Let's see if we can compile this thing. Yes. Okay. But I don't want to have the member variables in the public part, but something else. That is command add std string command. then arguments add a char pointer args arg values kind of something like this or something like that, and const std vector type def vec args reference args I don't know. I don't know. Okay, let's see. The return value. I think the return value is okay. Member functions, pool process. Shutdown function, yes, fine. 6 and ID child, yes. A lot of work to do. Okay. STD. What? Oh, yes. Okay, that's fine. Command add. Oh yes, the environment. Ooh. Let's say not arguments add, but arguments set. And we should have a function called environment set. This is a string vector. We have the same definition somewhere else. Should we reuse this thing somehow? I don't know. Okay. Okay. So this thing can be or command, yes. I don't like this. Vec env. Okay, I'm greedy. I'm so greedy. Time out set. The interface is the most complex part. If we have pipes create, if the list of commands, if not list of command size, then return positive in doing nothing. Otherwise, we need something like this, a zero terminated thing. The execution function, this function. The char const argument value argument is an array of pointers to null terminated strings that represent the argument list. The first argument by convention should point to the file name associated with the file being executed. The array of pointers must be terminated by null. Must be terminated by null pointer. Oi. The same for the environment pointer. Mm-hmm. Okay. Let's make a picture. Let's make a picture. Oh, come on. Node. Whatever. File executing piping. We have a component that is called file executing, and this thing should have multiple components. Okay, cool. Then we have child 2. In the near future, we want to have something like this. Child 1 should pipe the output to child 2. And we want to have another component like parenting. Yes, fine. And parenting should send the input to the first child and get the output from the second child. Oh. That's it. That's the thing we want to have. We want to be able to create multiple childs like this. Okay. Okay. So this thing should make a recursive execution of itself depending on the size of the command list. This means if if the size of the command list is equal to 1, is bigger than 1, no, equal, oh, come on, chain. So we try to, oh, that's dangerous. Okay, wait a minute. Oh, we have to be careful. Child done. These breaks are potentially dangerous, but okay. Because in the default case, we have one command in the command list. If we don't have any command, then we return positive. If we have more than one, then we make, then we create for each element in the list one file execution process, and we link them together. And if we have only one command, then we just create the pipe. Okay, return code. Let's see, man page of weight. Weight has an integer. Code return. String return, yeah. Okay. Timeout set. Okay. Yes, and oh, I forgot. We also want we want to have, yes, requirements. Multiple automatic sources and sinks, and detaching and or demonizing. Yes. Every time the same. Okay, demonizing. Sources and sinks must be. Pipe. Okay. Timeout set. We have a return code. Return string. Are we using this string already? No. Okay. We are not using the return code. We are not using the timeout yet. Okay. So this is fine. Let's make it step by step. The first thing we have to do is to define the interface, because we will use it later on very often. Pipe close, pipe init, ID child, 6 cent. $6 ID child, code return 6 cent. Return m code return. Status v. Terminated by exit. I want to make it in a different way. Signal. Yes. State signal. Core dumped. Signal. Terminated by exit. Terminated by signal. Check if core dumped. Stopped by signal. Continued signal 0. Okay. Then I want to have something like this. Bool child done. No, not done. Terminated. Child terminated. Signal child terminated false. Terminated by exit. True. Terminated signal core dumped, and then yes, we do not have a return code in this case. That's okay. Stopped. Stop signal. It's not terminated. It just got the signal. Yes. Code dumped or code return. Yes. So the child has an ID and has a specific state. Yes, I need return code. Return code. I need to know if the core was dumped. Yes, I don't need this information, but only as a function. Code return 6 send. Yes, bool. Yes, that's fine. Child terminated. Oh. That's cool. That's cool, I think. Okay. So, if we want to add I think we only need this thing. Oh God, what should we do with this one? Let's call it vec string file execution. Argument set. Okay, then we have environment set. Timeout set. This process is way too big. That's not a good sign. Okay, then for the execution, we have to change the current version. So this is how we add stuff. Okay, so this should be compilable theoretically. Does not have any. Okay, command. Oh, okay. Yes. Okay. Bah. From the command list, we derive from the command list we derive the command itself and the pointers. Everything we need for the exec VPE function. The pointer to the file, the argument list pointer, and the environment list pointer or pointer list. Okay, so we need something like this command. Yeah. Okay, yes. Start ms. Now this is a pointer null, mp command. Oh no, it's bad. Okay, but no C string then. Yes, that's okay. We need another state that is called sub-exec create. Pipes create, we say before we create the pipes. Exec param Okay. At this point we say mp command is equal to Buh. Proc warning block, nothing to do. Command list empty, nothing to do. Okay, we should get this message now because this command add function is doing nothing at the moment. Invalid conversion from const char to could not, was not declared in this command, command. Done. Command list empty, nothing to do, test done. Okay, that's fine. Okay, that's fine. Oops. So now we try our first error. Command add. We say we have an entry file execution. Entry FE. We say the entry FE dot command is command. Fine. The arguments. Should be cleared. Maybe. I don't know if this makes sense. Serve. We want to have arguments, say let's say 16. Oh, that's kind of a lot. Let's say 8. I don't know if this makes sense. Environment clear and reserve, yes, 8 as well. Okay. And then the list of commands, push back. Should we make a move? I don't know. Theoretically, we should have a different error message now. That is the error message from the child only if we are not redirecting the standard output. So let's see. Oh, that's fine. Could not execute file. That's exactly what we want. Yes, that's it. The file, the child told us that the file execution is the internet still working? Yes. Seems to be fine. Okay. Oh, file executing, piping. Wait. Status. Could not execute file. This was working using the char array. Okay. What's the state here? We have a child with a certain ID terminated by exit signal 0, return code 1. That's cool. Exit failure seems to be 1. No, that's cool. So let's change this again. Now we have a running process signal 0. We have a certain ID of the child, running signal return code. Then we can make this. We should be able to make a stop, stopped by signal 19, and then make a continue, running continued signal 0, and then we say can we make an exit? Can we make a normal exit? I don't know. This should be supported. Okay, we are registering another application close request. Can we make an application close request? Yeah. No, we should not. We should do something else because we can make an interrupt. And an interrupt means a normal application close request, and this thing should signum application exit. We make a hard exit here. Exit. Exit failure. A success. Let's make a failure. Okay. What? Okay, again. Running. Then we should have another sig user 2 terminated by signal 6. What? Invalid pointer. Ah, yes, okay. Oh, yes, okay, yes. Okay, this was the error like last time, and then terminated by exit return code 1. Okay, so we can terminate, we can make a direct terminate. That's fine. Okay. Let's do this again. Can we make a sig int? Yes, this is kind of working. Haha, we saw something already. We saw the execution of this line because we got a new line, and then this function tried to make an application close request by setting the unused bit in the app, but the way this app is working, it's not shutting down because this is a blocking call at the moment. And I'm not sure if I want this to be blocking. Because this is not the normal behavior of applications in Linux usually, I think. So I want to keep this like that. Okay. We have defined this thing. Change entry in. Can we change how to change an element of a std vector? Both return a reference to the indexed element, so you can simply use. Bound checking is priceless. Okay, that's okay. Okay, whatever. Can we change? Okay, yes, okay, fine. This means okay. Yes, the program the first thing we will do is we will set okay. We need more functions. Oh, this is a big task. We need another function. We need a send function. Do I want to do this? I'm not sure. Today I'm completely yes, invalid new expression of abstract class. So now we need to implement two functions, I think. That is the transferring interface. Address remote. Yes, these two functions, the send function, we would need to implement these two functions, the virtual send function and the read function. Code return. Read what? TCP transferring read. Oh, come on. Read ready. The read should be ready as soon as we have set up the pipe. Yes. I think pipes create fork parent start running. Oh, we have to, at some point we have to set the pipe to non-blocking, and I think we should do this here. To do set pipe to non-blocking on this side. I'm not sure if we can, we should be able to set one side of the pipe as non-blocking and the other side not, because we don't want to change the blocking state for the child side, but we want to change the blocking state on the parent side, and I think we can do it because we have different file descriptors for each end. So this should be okay. Should we create a function? Bool. File file blocking non-blocking set. Yes, let's see. Does this make sense? Let's see if this makes sense. Transferring a non-block block socket non-block. Okay. Yes, that's it. Why do we have different client argument check? Why do we have this non-blocking thing? Okay, if defined. Okay. Yes, we need something else, of course. An integer of the file descriptor. Return true. Keep alive. Socket op keep alive. That's something different. Then bool result is equal to file non-blocking set of msocket file descriptor. If not res could not set non-blocking mode. Okay, fine. That's an error log because it's here we have a success return, and this thing can be removed. We need this option thing here. Yes, okay. So let's see. Now we need unit tests, file executing, lib file system, that's fine, okay. TCP transferring. File non-blocking set. Good enough. Let's see what is happening. Okay, okay. Was not declared, yes. No, yes. Return false. Was not declared, yes, of course. Lib time, lib file system. No such file or directory. Why? Lib file sys, yes, okay. Makes sense. No return statement in file executing. Yes, that makes sense. Return 0. And we need void p data and len. And we need p buffer. Cool. Cool, now we can. That's cool. Because now we can set. We have. Hopefully we have. Oh, no, result. What? Why? No, not result. Come on. Ah, yes, it's not called result. The core transferring result. Yes, process. Yes, that's result. But that's okay. If not okay, yes. Perfect. And now in file executing we have bool okay. So let's see. Child. The child is not changing the non-blocking state. If that's so bad. Whatever. I think this should be working anyway. Okay, transferring bore. A non-blocking set. File executing. The pipe. std in. Right. Should be non-blocking. If not, okay. Could not set blocking mode. The same with std in, std out fd read and nope, std error. Now we are able to read, to implement the read function. If not, mready. Mready should be mready read ready und send ready. To read ready, send ready is true at this point as well. Okay. Okay. Now, pull. Oh yes. So. Oh, okay. We implement this function. Kind of the same, I think. Boah. I hope this makes sense. I'm not sure. Okay. Do we need a mutex? I don't know. Yes, we should use a file descriptor mutex. Okay, TCP transferring. Let's see. No. Fine. Okay, file executing. Read. We need this mutex for the pipe. Theoretically. Okay. Let's keep it that way for a moment. Instead of the socket file descriptor, we need the standard at first. Yes. The read function should a pair of file descriptors. Yes. Okay, we have int pointer mp read. No, just mfd read. Yes, that's it. Yes, that's cool. Okay. MID proc child, MID proc child. That's cool. Now. That's cool. That's cool, that's cool. And we want to set the read pointer file descriptor to this one. Okay. So let's see what man read does, and let's see what man receive does. Yes, receive. Calls are used to receive messages from a socket. They may be used to receive data on both connection, less than connection oriented sockets. This. Ooh. Yes. The only difference between receive and read is the presence of flags. With a zero flags argument, receive is generally equivalent to read too, but see notes. Also, the following call is equivalent to receive from notes conforming to POSIX notes. If a zero length telegram is pending, read and receive with a flag argument of 0 provide different behavior. Okay, I think we do not need Can we make a peak on a normal socket? Read attempts to read up to count bytes from file descriptor into the buffer starting at buff. On files that support seeking, the read operation commences at the file offset. If count is 0, read may detect the error described below in the absence of any errors, or if read does not check for errors. Mama, hi, Schraufi. Oh, we have a hard task today. I'm trying to implement executing the file execution process. So I want to be able to execute programs from inside our application. And this thing should be the best. So I'm quite greedy at the moment. Peak. I want to see why am I using this peak thing? We can use read here. Read is is taking a file descriptor and then a buffer pointer and then a count. Whew. So this is fine, and this thing yes, I know. Ooh. This is used. Ah, yeah. Ooh. I know why. For a socket, we have this argument, the peak argument. We can the process is reading is checking if the connection has the TCP transferring process has a function like yes, connection main, and this thing is checking if the connection is still up. So we have null arguments, and with the null arguments we can see if we have data in the buffer. We have data in the socket. And I want the same for normal file descriptor. Can we let's just make a test. If we can use receive. Was not declared. So today we have a hard task. File system. But if we have this thing, then it's cool. Has not been declared. Yes. File executing. What do we need? File. We have Unix stuff and yes, this thing if defined. Transferring. A lot of includes. Yes, that's cool. Disconnect. What is disconnect doing? Disconnect is closing. This thing is closing the file descriptor. I want to, yes, file system, okay. This function file fd close pipe init. Yes, pipe init. I want these three functions in the library to be in the library. I think that's cool. Exist. Yes, cool. Then we need the file descriptor pair to be in here. Okay. And then we need the include of the file system in the header. Okay. And I think that's it. And then this means we can disconnect error number. We don't need this, I think. FD close, I think, from file descriptor read. Receive bytes, what? I think we have to change this. Connection reset by peer. Ah, okay. Oh, no. That's fine. That's fine. Okay. Yes. I think we do not need this. But let's see what's happening. Okay. Bytes received was not declared. Bytes received. Yes. Okay. Statistics bytes sent. So this is just a long task we have to do. State bytes received. Sent. Bytes sent. Okay. Return code. Okay, this thing is doing something, but now we want to have read. Now we want to see if we are able to check if the connection Yes, I think we need this. I'm not sure if I'm making something useful today. Wait PID child supervise. Okay, we check the file connection. At the file state. fd read check. If this thing is returning, what can this thing can return something. Oi. Return num bytes. Peak, if peak. C, read file descriptor buffer. File buffer. To read the text within the buffer. Read pending bytes. Retrieve number of pending bytes for write. Check if it has bytes pending. See, read, get buffer size from socket. See, set socket buffer size. I want to be able to see the amount of data that is waiting in the pipe. The minimum size, the maximum size. Buffer. Set view not able to remain unbuffered. Holy. Today it's a hard task. Okay, we have a receive buffer size. Okay. Bytes received. Bytes received is bad. I think bytes received is bad. Bytes read. Bytes read. Bytes written. Read ready. Okay, bytes read ready. What is happening if this thing has concheck? What kind of error can we have? for a receive. Return value. These calls return the number of bytes received or minus one if an error occurred. If the event is set to indicate an error. When a stream socket peer has performed an orderly shutdown, the return value 0 will be a traditional end of file return. The traditional end of file return. Traditional end of file return. This is end of file. Debug log end of file. Receive failed. Yes. Okay, let's see. If this is smaller than 0, then return proc error log peak failed. Maybe we have to adapt the thing. Peak failed. Okay. If the peak failed, then okay. If it's bigger, then okay, that's fine. Byte sent, yes, not written. Okay, what is happening now? Receive failed, socket operation on non-socket. Okay, we can't use receive. That's fine. Okay, we can't use. Okay, we can't use receive. So we should not use receive, but read. Okay, that's see peek on file descriptor. Peek a file peek fd. Okay, can we peek here? What if we provide okay. On files that support seeking, the read operation so we can't use receive. Okay. Commences at the file offset, and the file offset is incremented by the number of bytes read. If the file offset is at or past the end of file, no bytes are read and then returns 0. Okay. Yes, fine. If count is 0, read may detect the errors described below. Okay, in the absence of any errors or if read does not check for errors, made. In the absence of any errors or if read does not check for errors, a read with a count of 0 returns 0 and has no other effects. Okay. Okay. On success, the number of bytes is returned. 0 indicates end of file. Okay. Mm-hmm. Confirming the POSIX nodes, the time. Can we peek on a file descriptor? How can a node in a bash pipeline peek at? Peek file descriptor. Peek FD. Do we have a function on peek FD? Peek at file descriptors of running processes. That's a function. Yeah. That's a program. Peek pipe. Is it possible to peek pipe file descriptor? Yeah. Damn it. I can write the buffer and you can broadcast by writing the data to a shared memory signal to read it. You wish to send message on clients. Okay, so we have to implement this thing in a different way. Okay. That's bad. That's bad. Okay, let's read this thing again. May detect the errors described below. May. So we can just okay. This has a lot of effects. Okay. Can we peek a pipe? No. That's so bad. That's so bad. Okay. One issue is the following. We have a process, and this process is starting, then it's processing something, and then at some point it's shutting down. When should this thing shut down? As soon as the child has been terminated, or as soon as there is nothing else left in the pipe, in the read pipe, or both. So we can't detect. We cannot detect if we cannot peek. So if we can't peek, then we can't have this thing. That's fine. Read ready. We do not have any read ready. If we do not have any read ready, then we do not have a peek. If not buffer or if not len, so we that means we cannot support a zero buffer this situation. Yes, fine. Okay, so the code is completely different now. If not ready, if the read is not ready, then return 0. If the read file descriptor is smaller than 0, then return 1. If we did not provide a buffer or a length, then return negative. Then this buffer, what? Where is this buff used? Ah, yes, yes, of course. So we do not need this buffer anymore. We can't use the receive. Yes, of course. Fine. So we have to read something. P buffer, len, what is len? Okay, len requested. We have to change this. Ooh. Len requested. Oh, okay, transferring. Oh, come on. Len requested. Now I'm now is the time to make a construction site. Okay, len requested, send len requested. Okay, that's fine. Oh, come on. Len requested. Len read, len requested. Read data len does not match. Requested. Len requested, len read. Yes, fine. That's the convention. Hopefully this is still working. Okay, len requested. If no len has been requested, so that's fine. Okay, received data. Okay. So we do not need a second read. Num bytes. Yes. Num bytes, that's bad. Let's call it len read. Yes, that's it. Perfect. Num bytes read. Yes, okay, kind of. Receive data, let's see. If it's smaller than 0, if again or would block the normal case and the K, otherwise we close the socket. We say read failed. If not end of file, then okay. Okay, that's fine, I think. Okay, let's execute this thing. Peak failed. Yes, that's Let's talk. Read. We cannot peek, so we have no check. We have to remove this thing. We can't read anything. Okay, that's cool. And now the process is running. We have not read any stuff and we have not written anything. Okay. I think the pipe is set to non-blocking, so that's okay. That's fine. The pipe has been set to non-blocking. Oh, come on, we are already at 500 lines. This is very bad. Okay. Length. Ready. Ready. FD read. That's not okay. That's not okay. Ooh. Should we throw an error? Error. Yes. I think we should throw an error. Hopefully this is okay. Read. Again. Otherwise we get a read error. This is end of file. And we indicate that there is no more data. So the return value of this function is return bigger than 0. No, I think this is indicated in the transferring thing. Nope. Yes. Phew. Return value is here we have this documentation, and this documentation should be moved to the transferring process. The return value is greater than 0. A number bytes read. No data at the moment means 0, but data can be expected in the future. And smaller than 0, no data can be expected in the future. Okay. And the same we have here. If we have an error, then return. If 0, then we may get data later on. Okay. So this is not an error because that's a normal case. only here we have an error log. Receive data. Okay, okay. Bytes read, bytes written. Okay, that's fine. Now, we have to implement the arguments because file execution, the testing, transferring header, okay. The testing should now np exec. We want to add arguments set. How many? Three of them. Unit tests. Test, for example, and then we say I don't know if this is working, but hopefully. I'm not sure, but let's test this thing. No matching function call. Bracing closed, initialize list. C function. Pointer list. P function. How can I use an array of function pointers? Yes, I want to have something like this. Language pointer as function argument. Passing pointers to functions in C. Passing list of pointers to function. Passing an array containing pointers to a function properly. Ja. A, B, what? Maybe file executing. Arguments set. What's an array? Okay. No. Passing arrays of pointers into functions. That's not what I want. That's not what I want. We have several options. This is a not working option. Pass array initial arrays in a body as function parameter. It works. This is about initialize the lists. Cool, what the hell is that? I've never seen this before, but this looks cool. Okay. Argument set. Oh, initialize list. std initialize a list of a char pointer. That's the argument. You like this. C++ forbids converting a string constant to char pointer. A const char pointer. Okay. Undefined reference to initialize list. Yes, okay, fine. That's because of this. Oh yeah. Nice. What's an initializer list? So now, okay, that's interesting. Only the compiler can create an initializer list, but you can treat it like a standard STS container and random access iterators. Oh, random access, that's cool. And I explain some other containers can now be constructed with initializer lists. So, is equivalent to okay. Fine. Oh, that's a good idea as well. If it's not available and the arrays are mostly small, there is another option. Oh, we could we could make something like this. MP exec foo go sleeping bar. Poor. I think that's cool. Can we create an initializer list from something like this? Phew. Yes, the interface is the most complex part, I know. Can we do something like this? Char const char pointer args is equal to this thing args. Can we do this if we don't have that? No, that's not. Object args requires one element in initializer. Yes, no, that's not working. That's not working. Because I have to do this instead. No matching function call to. Yes. Makes sense. I don't want to have multiple functions for the same thing. I want to have one function. There are multiple cases. How I want to execute this thing. How I want to use this thing, and we want to have only a few functions that support as many situations as possible. Boah. I think I need a beer. Oh, that sound. This process class is very important. For me. I want this thing to be as convenient as possible. This looks very neat. This looks amazing. But the problem is that we need to assign arguments as well as environment variables. This thing is ugly and it's error prone. We could do something else, but this is error prone as well. We could make a variadic function, and this variadic function needs to be terminated. We could theoretically make something like this. command args set. I think this is the best solution if we make this as a macro. It looks kind of beautiful. Then we could do the same with the environment. How did we, in which class did we use this? There was a place we have used this. It was in the file logs. Somewhere in the file logging. It was in the file system. Yes, this is it. We have variadic arguments and we execute. Yes, we execute the function with the variadic arguments plus null. And the function has at the end variadic arguments. If we use an initializer list, then we do not need an argument count, I think. Because the container should have the count inside. Yes, so this is okay. So we can remove this. If this is the case. So this is the first option. That's the second option. And that's the third option. The fourth. And the fifth. We could, so let's see if C++ initializer list, CPP constructor member lists. I want to see what kind of container this is. That's so bad that we can't use this operator. This operator is kind of cool. This would be cool. We cannot use this. We should not be used because and cannot be set the same way. That's bad. Okay, so we can't use this. The initializer list is cool. So I want to call it method like we could cast this thing. Yes, okay. That's I don't want to cast. I don't want to cast. Initialize a list. Okay, read. Blend tech. Oh, come on. Forking. Piping. Start UML. Save. Close. Okay, that's cool. Piping. Oh, we want to peak FD. We do not need this. How to do a socket buffer size? Okay. Check if there has been anyone for escape sequences. Okay, and that's it. No, that's not what I want. A CPP reference I want to use. C++, yes. Okay, that's cool. So we class template. Template class initializer list. This should be some kind of container, I think. Member functions, non-member functions. We have a size, returns the size of the list. That's cool. Iterate the beginning. Is this thing some kind of like a vector, for example, vector, other input containers, vector, because I think the class is vector, generic terminal class, vector, container properties, sequence, member types, member functions. Member functions. Okay, containers, I think. Is it possible to convert an initializer list from a vector and back? Initializer list to vector. What the hell? To a vector. So do I need to use a follow-up? No, in order to initialize model of type, you should use the member initialize a list of the constructor motor group. Okay, this, remember initialize a list, yes. Try motor vectors vector form. This is strange. Why this? Curly bracket. Okay. Can we? Yes. Okay. Maybe this is the reason why this was not working. Const char pointer. No matching function call. Okay, yes. So I don't want to have this type, I think. Let's see. Okay. Invalid conversion from const char pointer to char pointer. Yes. Of course, const. Oh, that's so bad. Of course. Invalid. This is not implemented. This is not implemented, and this is not implemented at the moment. Okay, why is this working? So now this is working because, oh, that's better, that's cool. Vec const char. That's cool, because I think we can skip the initializer list then. Exit. No. Okay. That's better. So we can't use this anyway. That's cool. We do not want to use this anyway. That's okay. This is I think we are finished. I think we are finished because now we can we need this we have this situation sometime, and we can use this one, and we can use the third one. That is, we have a vector const char of something. Test is equal to. I don't know if this is working. Oh, come on. And I want to be able to... This should be the third one. And I think we can skip this one. Yes. That's cool because the first function supports this situation. We have, for example, in the main. Function. And the second function, the reference to the const char vector, is supporting the initializer list because it can be casted to a vector, and this one. And these two cases are very often used, I think. That's cool. I think that's cool. Yes. Okay, so that means we can implement this this thing, and we will test all three cases. The first one is this one. Argument set. Oh, If not command list dot size return. Oh, yeah. Argument set, okay. List commands, Otherwise, size t index is equal to this one. Let's implement just the first function, okay. If index size, okay. If not index, but if we have index, then we say index. Okay, dot args. While argument count 4. Push back. Ah, come on. Okay. Size t is equal to 0. I is smaller than argument count plus I. Argument vi. Yeah. Okay. I think we would be able to do this. But I do not want to do this. Okay. So argument set, the first one. Okay. That's cool for me. Now, if we start the parent. No, yep. Exec params derive. Yes. Oh. We have to create this pointer structure. Are we able to vector to no, we can't do it like that. I think that's bad. At which point? We should not do this in the parent. We should not do this in the parent. Because the execution function is used in the child. Oh, come on. Okay. Fork. Yes, fine. Fork and then let's make a function that is called child setup. Protect the private process void child setup and initialize child execute. And in this function we want to do all the stuff from child execute. So this thing is not returning because if we have an error, then we have an exit. Or this is successful and it's ending at this point. Okay, so the whole thing from here to here, yes, should be put into this function. So this function is in this function the child goes to another dimension. Okay. But so we are removing the signal handlers. We are closing the pipe stuff. And now we in this thing we have to create the execution parameters. So this was not the best idea. Pipes create, yes, okay, init, pipe init, and then we have the child execute and the child execution. Ah, that's cool, I think. Hopefully. We can do a lot of stuff. We can do, yes, that's cool. We can do a lot of stuff. And at this point, we have to derive the, and we do not need this as a member function anymore. Yes, perfect. Using command, yes. That's okay. We can do this. That's okay. Let's check this. Here we have const char pointer p command is equal to this thing. Yes, that's fine. So I think this should be this thing should still be working. Unused variable, that's true, yes, and true and cool. That's true and very cool. That's testing. So the sequence of the stuff is very interesting. And here we have the arguments. Then we have the p command, p arguments. Yes, p arguments. That's fine. So these three things have to be used at this point only. And we simplify this thing. Because we do not need this very long. Yes. Oh, I have to be careful. I don't want to break the format string. Okay, come on. I should search for error number. Yes, that's the same. Error number. We just want the error string, not the error number. Don't care. Okay, so we have the child execute function. We do not convert anything if we get an error. Now we are able to let's make a file entry pointer. Res was not declared. Yes, fine. This is still used. That's okay. Result. Comparison integer differs. Yes, of course. Because we have an index who, let's say, integer. Is this okay? Oh, I don't know. That's okay for me. Forking using command, that's fine. Let's see. Running. Stop. Continue. Interrupt. Sig terminate. Ah, yes. No, this is strange. What is... This is still working. Oh, yes. I always forget that... that the child process is blocking. That's okay. Seems to be fine so far. Okay, now the interesting part. The cool thing is now we have p arguments is equal to, we allocate something, not malloc, come on, new. I'm such a C++ noob. C++ new array. New type. Oh, come on, what the hell? Can we do what? Okay, yes. P entry. Arguments dot size plus 1. If not, couldn't execute files, then we have to delete the arguments. And then we can peacefully die. Then we say for Come on. And plus iter. That's so stupid. No. Back to the root. Size t I is equal to 0. Okay. And now we can say arguments. We can say p arguments count is equal to null. If we have one, yes. If we have zero arguments, then this is 0. We have at least one argument, and the first one 0 is null. Okay, fine. Oh no. Yes. Plus 1 is gleich null plus 1 is the command. Oh, so 0 is p command. Crazy. Okay, so form 1 is equal to let's say vector. And what can a vector do? Operator. Do we have yes, I think that's fine, because we have a vector of const char arrays. So this is a const char, of course. And we want to print this thing. We can only print this as long as we have to be quite silent in this case. So we are not allowed to keep this message, but at the moment proc warning log using argument count. If 0 and if we say 1 from I to count plus 2. No, that's from count. Oh, we have to be careful. We have to be careful. Yeah, because that's shifted. That's shifted. We have to, yes, of course, from 0 to smaller than count. we save all the arguments +1. Yes, that's it. So the first argument is at position 1, but we are reading from 0 and only count because we only have size. That's the source. Yes. Okay. And in this case, we have something different. We are iterating through this list. So we have proc warning log using argument. Arg is equal to I p arguments I. That's it. We are not redirecting the pipes, so that's fine. So we should see the this list, and this list should contain at the first position the command, then all the arguments we have given, and then we have given at this point, and then we should see the last argument should be null. And yeah. And let's see. Oh, come on, expected type specifier. What the hell? Yes, of course. New. I do not know the new syntax. So I'm so ashamed. But I don't care. Okay. New. Okay, new like this. What? How can I? Yes, and no throw. Yes. Ooh. Very important. No throw. So if not yes, could not allocate could not allocate arguments if not p arguments. Boah, come on. Boah. Fine, and here we deallocate the arguments. Yes, and we have a no throw, and we need a const char pointer. can we do it like that? I don't know. Incompatible types in argument. To const char, what the hell? Yes, of course. Oh, come on. This is the node row must be. This is an argument somehow. Yes. This argument, and then the type. And then how many? Makes sense somehow. It makes sense. Okay. Yes. Array bound forbidden after parentized. Yes. Oh yes, of course. That has changed, of course. That has changed now. Invalid conversion from construct pointer to, yes, I know. To char pointer, constant pointer, what? Yes, that makes, that does, yeah, boo. Char pointer const, what? Char? Okay. I've never seen this thing. Okay, execution. What does this thing want? Char pointer const. Char pointer const pointer. Char pointer const pointer. And then we have a char pointer const pointer. I can't believe. Okay. Can I convert char const pointer to? Yes, this seems to be fine. Yes, no, yes, I don't know what is happening. The best way to do this is to try and error. Fuck. Okay, new const in new. The hell. So what is this thing? Char pointer const. Yes. So I have to make this Yes, that's a good position. That's kind of a good position. Okay. Invalid conversion from const char pointer to char pointer const. So we have a char pointer and then const whatever. Uninitialized const in new. Oh, I don't know what is happening. I don't even know what. Okay, what that's. Yes, that does not make sense. Okay, we have. Okay, the arguments. We could write. So that's fine. New. No throw. Of the type. Execution. We have a char pointer. This is confusing me so much right now. Oh, come on. Yes, I think this should be working if I say char pointer const and an array. Maybe I have to. Uninitialized const. What the hell is going on? I don't understand the type. Char pointer constant. So we have a pointer to a constant char. Here we have a pointer to a character and we have a constant pointer. Constant array pointer. Yes. Read assignment of read-only location. Yes, we don't want this, of course. Oh. command, p command is, yes, const char pointer. Yes, because yes, now I understand. Now I understand that we don't have a const at the left. Oh, come on. Oh, come on. Please not. Please not. Come on. I have constant pointers. I have constant pointers to the array from the vector. And this function wants a character. No, come on, why? It does not want a const. It does not want a const. Come on. This means I have to make a string duplication. Ugh. I don't want to make a string duplication, but I have to. Oh, come on. Okay, whatever. Okay, so this means I make this. That's fine. And I make this. That's fine as well. I use str duplicate Oh, come on. Oh, okay, yeah, C++, of course, okay. No, stop. Yeah, whatever. Okay, const char, yes, from const char to character. Returns a pointer to a new string which is a duplicate of the string S. Memory for the new string is obtained by malloc and can be freed with free. So we have str duplicate from command. Command is a const character, and this entry is a character pointer. But then we could do this. Yes, we could do. This is a const. I think it's allowed in the other way around, so we do not need. We can just do this one. Okay, so we do not need this. Is the duplicate of this one. Should we use I don't want to use new, I want to use calloc. Copy alloc. Come on, man, calloc. The malloc function allocate size bytes and returns a pointer to allocated memory. The memory is not initialized. If size is 0, then returns are null. Returns whatever. Otherwise is free different behavior. Calloc. No. Yes, is set to 0 if yes. This is there is another function. There must be another function. I think. Okay, no, I'm fine. Malloc size and mem. What's that? Oh, that's interesting. Ooh. Allocates memory to an array of elements of size bytes. Okay. Bytes. Okay. So again, p arguments is calloc of count plus 2 size of character pointers. That's okay. Free. Then we say we duplicate the entry, the command. Then we say this is null. Yes, okay. I'm okay with that. Child execute and then args delete. child args delete. Oh come on, it's we are at the end of the stream already. Okay, so we have yes, of course we need int argument count char pointer argument v. For side int e equals 0, e smaller argument count plus I if not argument value continue, otherwise free of can free the function returns no value. Freeze the memory which must be returned by previous call to malloc. Otherwise, has been called before. Undefined behavior. What? Otherwise, if pointer is null, no operation is performed. If pointer is null. The hell? It's okay. Okay. Let's keep it. Let's keep it kind of simple. Okay. Okay. And then we should be able to make this thing. Argument count? Yes, okay. That's special. Okay, could not allocate arguments. If not, then just return this and I think that's working. If not this thing, then Okay, count arguments full. Count arguments. Yes, we see that there are many bugs. That's okay, that's cool. -1. If we are not able to I want to do it in a different way, because I say if not index, yes, that's cool, we make a duplicate yes, arguments arguments full -1. Yes, that's it. Bad. Okay, so we have, this is not necessary actually, but I don't care. So and arguments, oh come on, arguments full, couldn't argument allocate argument, memory for arguments, could not allocate memory for argument whatever. Okay, so we have an entry, we have the pointer to the entry, we have a number of arguments, we have the number of arguments full, we add the command and the null pointer, we have a const char arguments, we have a char pointer arguments, then yes, completely crazy. Yeah, but okay, let's move on. We allocate the memory, initialized with 0. Number of arguments is full. Character pointer. If not, could not allocate arguments. We provide 0 in this case because we can skip this for loop then and only free this thing. Okay. We will test all the stuff. Could not allocate memory for arguments. Delete. Exit failure. Nice. Then we initialize the last entry and then we say if not index. We go through all the arguments full. -1. If 0 index, then we duplicate the command, otherwise we duplicate the argument entry. Yeah, we have to be careful. Now we have a different I indexed. We will rename this to index full and index full if not index full, then it's doing this, otherwise we can use -1 here. I think that's it. If there is something happening inside the allocation, then we could do it much simpler if I just cast the thing, but I don't want to. Whatever. Okay, arguments full. Yes. Index full. Index full, index full, index full. Okay, cool. Invalid conversion from, yes, whatever. White pointer to char pointer, yes, okay. Char pointer, yes, let's see. Cannot convert to const. Oh, okay. I thought that this is... I have to cast at this point, but I don't need to. I just fucked up. I think this is the way to do it. Invalid conversion. Yes. No, that's fine. Now the next thing. Yes. Okay. Okay. Why is this? Okay, was not declared. Yes, p command. P arguments at 0.0. Okay. If don't care. Okay. That's kind of cool. So let's see. That was a journey. we see that okay. We provide. Okay, that's cool. So we have, that's perfect. We see these arguments. The first argument with index 0 is the command name. Then we have our three arguments, foo, go sleeping, and bar, provided by the testing thing, like this. Cool. Then the last one is null. So we should have 5 entries in the argument list. The first one is the command. Then we have our three parameters, the real the arguments, and the last one is 0. Come on, oh, that's so fancy. Okay, so we can remove this thing, execute the command using command. Okay, so we can fine, and as you can see, the oh, that's cool. Yes, that's cool. Very important. Transferring, standard, providing main C. Yes, that's cool. Number of arguments is perfect. Fine. And now we do this again. The number of arguments is 4. We have 5 entries in the list we give to the exec function, because this is a null terminated array. And this function is checking this list and is checking how many entries we have that are unequal to 0, to null. So this function is giving the main function of our child the number of arguments in this exact list, but there should be, I think this is the exec function is providing the same list, so we should have a null element after the last argument. And that's the reason why we provide 5 entries, but we are reading 4 arguments. The first one 0, and then we have the last 3 arguments. That's kind of cool. That's kind of cool, and I think we will check the last mechanisms. Oh, that's so fancy. So yes, yes. Oh god, I don't know. This is so much code for very, very little benefit. That's a lot of code for almost no benefit. But whatever. Okay. Okay, yes. Argument set. Now again for the list command size. If not, then I want to C++ vector. No. C++. Come on. Vector. And this vector has a constructor. Vector. Come on. No. C++ vector from argument count and argument v. Arguments. Range Constructor. Der Range Constructor. Oh, that's interesting. Oh, that's interesting. Ah, that's cool. Okay, because I want to say if not index, then return otherwise minus index. The current index of the list command we say we have const iterator iter is equal to argument value begin, and then we say iter is not equal to argument values and plus iter, and then we say push back iter. If we can do this and we have the same output, then that's cool, because now we can say we are just executing this function with a vector argument v plus argument count. It's not the same because here we have the argument count from a main function, and we have just the arguments, the in arguments. Missing template arguments before. Yes, of course. Because we need, of course, this one. Expected primary expression. Yeah, okay. Argument set. Oh yes. Okay, then we need again to test the upper case. What Okay, it's working. It's still working, that's fine. So in any case, we see all the arguments. This should be fine as well. Perfect. So we have two functions and only one function is doing something actually. This is saving so much space. Let's try this out. I think that's okay. Not index, and after the check we decrement, and we do not care if we decrement after the return. So if this is 0 and we decrement, we are at FF, but we return. Otherwise, yes, I think that's okay. So for the arguments, we have kind of a small function. We do not need that stuff. Okay. Because this should do the copy constructor. So env set vector const character and commands list size now minus minus, yes, return environment index, yes, okay. Okay. Now, oh, come on. And yes, the same thing needs to be done for the environment. I don't know if we can do something like this. Oh, let's test this thing. What is happening here? Forbids converting a string constant to character pointer. Yes, that makes sense. That makes sense. We can't do this. That makes sense. So the conversion from a vector of const I don't want to do this here. We could. Okay. Yes, whatever. Okay, this is fancy, and yeah, I think we are one step further because we can add some command, and we have 3 ways to provide the arguments. The command is quite easy because it's just a char point or a const string reference. Oh, boah, the hell. Const string reference. Command add. This should be fine too. Okay. I think we got closer. And in the future, I want to be able to do something like this. And then that's the cool thing. I have command 1. And then I want to use this. And then I can just add a second command with different arguments. And we should be, this thing should be able to connect these 2 commands in an internal pipe. And I want to send everything I send to this parent file execution thing should be redirected to the first child, and everything I read should come from the third child. That's the goal. And I think that's okay. We can compare this with the Rust thing. The directory checksum is an execution builder for example, unmod argument directory, but shell shutdown join. Okay, join. Yes. Okay. That's it's unwrap. I think it's some kind of unwrapping. I don't know. At least it's joining. It's waiting for the unmount process to be done, or this thing. Okay, stream standard out. Yes, that's the stream. Looks quite cool. Standard out. Yes. Okay, that's the redirection to the pipe. Merge. Oh, that's, yes. Kind of like that. That's quite cool. I want this thing to be the default. The default should be an own internal pipe. And we should be able to add a point where the process can sync or source the data. Okay. Yeah, that's big project. This process is kind of heavy. Okay, that's fine. That's cool. What's end up? Yeah. But copies at most n bytes. If s is longer than only n bytes are copied and the terminating null byte decided. But use alloc a to allocate the buffer there. Okay. Conforms to POSIX. And this as well. Okay. Read. Pipe function control, that's fine. Pipe fork loop exec. File execution, yes. So the argument requirement is finished, I think. So for the future we will use this type. It's still running. We can stop this thing and we can continue. That's cool, that's cool. Okay. Very strange. Okay, so now let's finish the stream and let's rate someone. This was a hard session, and the next session will be very difficult as well, but I am fine with that. Toggle bit. Let's see what they are doing. Brotla. That looks cool. The build class is playing its game. It's almost finished. Fork for YouTubers. Let's make it in React. Okay, I'm not into React today. A keyboard build. That sounds cool. That sounds cool as well. Now let's rate Brutzler today. So was a hard stream today, but we finished some stuff, so it's kind of okay. See you next time. The next streams will be quite hard as well. Very, very special, but we will have a fine thing. Oh, 4 viewers. Thank you very much. See you next time. Bye.